Okay, so I'm continuing after replacing the batteries in the class mic with calculating this series. So I've defined this function series with a tolerance. So the calling program simply calls the series with a tolerance set to 1 times 10 to the minus 5, as was given in the second bullet in the instruction. Right, so what the series does, it first initializes the value k to 1. Now, it's perhaps interesting, sometimes this counter, of course in record 15, the counter is incremented with 1. So it's like a loop counter, counts how many times it goes through the while loop. Sometimes we initialize this counter to 0 and sometimes to 1, and you can actually initialize it to a different value also. So the question that you need to ask yourself is, to what value should I initialize this counter? And it really depends on what you're trying to do. It also depends on where in the loop you're going to use the value of k. So if k is merely a loop counter, you can increment it at the bottom or at the top. That doesn't, because you're not using it anywhere, you're just counting the number of loops. But in this case, the value of k is actually used in the calculation in record 10 and 11. So if you decide to increment the loop counter at the bottom of the loop, then you need to answer what value I should use in record 5 should then be determined as what is the k value of the first term in my series. So if I go up to this, I see my first term I calculate in the series is when k is 1. So it means that I need to here have k equal, I need to initialize k to 1 if I choose to increment my k at the bottom of the loop. Alternatively, I can make k 0 here, but then I need to increment k before I calculate term in record 9. Okay, so you need to take note of that. There are more than, it's always in computer programming, more than one way of doing what you want to do. So don't be confused with k being initialized to 1 here as opposed to loop counters being initialized to 0 in previous examples. Right. Okay, so error is initialized to 1. That's quite similar to what we've done before. Whenever we had tolerance to chase, we start with the error value is rather large, and then as we go through the iterations, the error becomes smaller and smaller until it meets the convergence criterion. Right, so in record 8, we then go into the while loop with the condition that error, the condition for continuing in the while loop, of course, is that this is true. In other words, the error is larger than the tolerance. So, of course, since the error is 1 initially, and the tolerance 10 to the minus 5, it will certainly go into the while loop at least once, and probably a number of times. Then in record 9 to 12, I'm calculating just a single term. Remember now, I'm using the while loop. Every time it goes through the while loop, it calculates one of these terms. So this is the first time through the while loop, then that will be the second time, etc. Now the calculation of one of those terms is done in record 9 to 12, and I use the name term. It's just a name. I could call it anything else. So the term is calculated in a multi-line calculation, and because of that, I start with the open bracket, and I close the calculation in record 12 with the close bracket, and then what you see is that in record 10, I have the numerator, and in record 11, I have the denominator. And I use the math sub module from the NumPy module. NumPy module was important, the global namespace. And then the factorial function in the math submodule. So in the numerator, I calculate the factorial of k and I raise it to the power of 2, which is what I have here, right? Factorial raised to the power of 2. In the denominator, I need to calculate 2 times the factorial, 2 times k and then the factorial of that. So that's why I pass 2 times k. I must be very careful now, sorry. I pass 2 times k to the factorial function for the denominator. And then, of course, once it's done this, the numerator is a number the denominator is also a number, and it simply divides the one through the other to calculate the term. And then, of course, I'm going to add this term to my approximation. So the approximation is called approx. That is really the answer. Of course, approx is an approximation to what I have on the left-hand side if I do not include all infinite terms. So if I terminate the summation before I get to infinity, for k into infinity, I have an approximation. But of course, as I include more terms, I'll get a better approximation, right? But that's why the answer is called approx. It's really for approximation. It's just a name. So I calculate, I add the current term to the approximation. Of course, the first time it goes through the loop, approx is 0. And so term will be the first term, but then it carries on like that. Then in record 14, I redefine error as the absolute value of the term. So in other words, in this case, when it says that it should converges with an error of 1 times 10 to the minus 5, the implication is whenever a term gets smaller than that, it will stop the summation. Right? So because of that, I redefine error as the absolute value of term. I increment the loop counter, and I then carry on through the loop again. Once my error is smaller than the tolerance, this condition is no longer true. It's false, and then it will not go into the while loop. It will jump the while loop, and it will return to the calling function. Okay. I see that I'm 5 minutes over the time, so I think what I'll do is I'll demo this function after we had a break for 10 minutes. So we'll reconvene at 16:35.